This presentation is divided into two sections. In first section, we'll discuss the concept around Kubeadm. First, what is Kubeadm and what it does. Then, we'll discuss about the commands related to Kubeadm. So that's about the section 1. After that, we will review the demo we are about to perform on a live system. This will help you better understand when you watch actually doing it live. In this review demo, I'll show you what are the prerequisites required before you install Kubernetes. Then we'll install the software applications related to Kubernetes. After that, we will configure the Kubernetes master node. Then we will configure the Kubernetes worker nodes and join the worker nodes to the cluster. And finally, we'll test and validate entire setup. So that's about the section 2. In case if you are looking for a live demo on installing Kubernetes on Kubeadm on the system, then please do check the links in the description below. And now, let's get started with what is Kubeadm and what it does. First, let's discuss about what is Kubeadm. Kubeadm is a command line utility which will help you to bootstrap your Kubernetes cluster that conforms to the best practices. So before Kubeadm, things were very complex and time-consuming to configure Kubernetes cluster. So if you are just curious how hard it is, then just Google Kubernetes the hard way. The results will show you the Kesley Hightowers how to guide in configuring Kubernetes hard way. But luckily, with the help of Kubeadm, all that complexity was hidden and made it a lot easy for newcomers to configure Kubernetes cluster. If you are new to Kubernetes, then you can start with Kubeadm to try Kubernetes, and which will make your life much better. If you are someone who are already familiar with Kubernetes, then you can spin up the cluster with Kubeadm and test their applications. So now, let's see what are some of the operations that you can perform with Kubeadm in next slide. In this slide, we'll go through some of the Kubeadm commands. First command is Kubeadm init. Kubeadm init will initialize the Kubernetes master node. So run this command whenever you want to configure any node as master node. After Kubeadm init, next thing we are going to look at is Kubeadm join command. So Kubeadm join will initialize the worker node. So run this command whenever you want to configure any node as worker node inside the cluster. Let's review it again. We have a Kubeadm init to initialize the master node, and we have a Kubeadm join command to initialize the worker node. So these are the two most frequently used commands when it comes to the Kubeadm. So there are few other commands that you might want to be familiar with. At a high level, Kubeadm token command. This command will help you create tokens. Next comes the Kubeadm version. As its name implies, Kubeadm version prints the version of Kubeadm. And final command here in this list is Kubeadm upgrade. Kubeadm upgrade is a user-friendly command that wraps complex upgrading logic behind one command. So with the help of Kubeadm upgrade, we can upgrade the Kubernetes and also we can downgrade the cluster if necessary. So these are some of the commands related to Kubeadm, and there are some more available on the website. Overall, Kubeadm init and Kubeadm join are the two commands that you might want to focus extra on this one. Overall, you might want to more focus on Kubeadm join and Kubeadm init in this video. So with that, let's move on to the next slide. Before we get into the details, I just want to quickly show you how Kubernetes architecture will look like and what are the components Kubernetes master and the worker node has. As you can see, Kubernetes master consists of API server, scheduler, etcd, and control manager. Here, API server is kind of a gatekeeper for the entire cluster. If you want to create, update, delete, or even display any Kubernetes object, it has to go through API server. Next, scheduler. It is responsible for physically scheduling pods across the nodes inside the cluster. Next, controller. Controller is responsible for overall health of entire cluster. It ensures nodes are up and running and correct number of pods are running as mentioned in the spec file. And finally, etcd. etcd is going to be the Kubernetes central database to store entire Kubernetes configuration, including objects it is creating, secrets, and more. It is a key value database. Any component of Kubernetes can query etcd to understand the state of the cluster in real time. And now, moving on to the node components. In Kubernetes worker node, we have 4 more important components, and they are kubelet, kubeproxy, pod, and containers. First, we have kubelet. It is a primary node agent that runs on each worker node inside a cluster. It looks at the pod spec that was submitted to the API server on Kubernetes master and ensures that the containers are described in the pod specs are running and healthy. In case if kubelet notices any failures with the pods running on this worker node, then it tries to restart the pod on same node. Next, kubeproxy. Kubeproxy is a critical element inside Kubernetes cluster. It is responsible for maintaining the entire network configuration. It essentially maintains the distributed network across all the nodes, all the pods, and across all containers, and it also exposes services to the outside world on the internet. Next comes the pod. Pod is basically a scheduling unit in Kubernetes, just like VM in VMware world. So each pod consists of one or more containers. In most cases, there will be one container. So the primary advantage of pod is we can deploy multiple dependent containers together. So it acts as a wrapper around these containers. Finally comes the container. It provides a runtime environment for your applications. So you run containerized application processes inside these containers. So that's about the Kubernetes important basic components. Now we'll look at the process of creating Kubernetes master and the worker nodes. Finally, at the end, we'll deploy a sample application to make sure everything is working as expected. Now it's time to go through some of the steps involved in creating Kubernetes cluster with master and node. This is primarily divided into 2 subparts, that is installing and testing. So before we go ahead with installation steps, let's review the prerequisites for setting up Kubernetes cluster using Kubeadm. So coming to the prerequisites, first thing, make sure the VMs that you're creating as part of this setup has at least 3 GB RAM and 3 virtual CPUs. These numbers are based on my experience. You might see these numbers bit less on official documentation. And next requirement is to have a full network connectivity among all machines in the cluster between the master and the Kubernetes worker nodes. Next is to disable swap on all nodes. And the final requirement here is to disable SE/Linux. You have to do this until SE/Linux support is improved in kubelet. Now, let's take a look at the steps involved in creating Kubernetes cluster in next slide. In this slide, we'll discuss about the 6 steps involved in creating Kubernetes cluster. So in the first step, we'll create the VM which are part of Kubernetes cluster. In next slide, I'll show you how many VMs we'll be creating as part of this Kubernetes cluster. Then, we'll disable SE/Linux and swap on all nodes. After that, we will install the 4 packages. They are Kubeadm, kubelet, kubectl, and Docker on all nodes, including Kubernetes master and the worker nodes. And the point to note here is Kubeadm will not install or manage kubelet or kubectl for you. You have to manually do that. So once the installation is done, then make sure to start and enable Docker and kubelet services on all the nodes. Then the first step is to initialize the master node. So during this process, all the required components will get installed and configured on the Kubernetes. So during this process, all the required components will be installed and configured on the master server. So can you guess what is a command to configure Kubernetes master node? If your answer is kubeadm init, then it is right. So we will initialize the master node with kubeadm init. And once you configure the Kubernetes master node, and before you join Kubernetes worker nodes, and there is one more step, and that is configuring pod networks, where all pods can communicate with each other across all the nodes inside the cluster. So there are various network plugins to configure pod network. And some of the network plugins we can use are Wave, Flannel, and Calico. In our example, we'll install the Flannel here. Once that is done, the final sixth step is to join the worker nodes to the master node. Then we are all set to launch our applications on the Kubernetes environment. So before we move on to the next slide, you might want to pause this video and observe these 6 steps again. These are the exact 6 steps that we are going to perform in this video. I believe you are good with it. And let's move on to the next slide.